Assalamualaikum and hi. Today our group will be presenting our summary and critique on the paper we have chosen, which is about the optimization of toolpath planning and CNC machine performance. Okay, for the first we'll begin with the summary. So essentially, it just investigates how to reduce CNC machining times. The authors of this study modeled 4 pocketing strategies, which they call spiral in, spiral out, one way, and zigzag. These pocketing strategies were tested on 3 subjects, P1, 2, and 3. The conclusion made by this author was that toolpath selection does depend on workpiece geometry, and that combining commercial CAM software with G-code optimization tools can lead to high efficiency beyond what a single CNC simulation package provides. Okay, next.
Moving on to the clarity of the research questions. Next. The paper aims to optimize CNC milling time by varying toolpath strategy, machine speed, and G-code. This aim is identifiable, but it isn't framed as one clear research question or hypothesis. Instead, the introduction blends 3 separate objectives together, comparing 4 toolpath strategy, evaluating the effect of machine speed, and demonstrating a multi-software G-code optimization workflow. Because these are presented together without a clear hierarchy of primary and secondary objective, the reader is left to infer what the paper's central contribution actually is. Is it the toolpath comparison, or is it the additional time reduction achieved through the supplementary software? Overall, a more explicitly stated research questions with clearly separated sub-objectives would have sharpened the paper's focus.
Looking at the appropriateness of methods, simulating in iCAM 3D and validating on the Intermec CNC machine makes sense for an applied study. However, 3 main limitations weaken the conclusions. First, no repeated trials were run, so we have no variability or standard deviation data. Second, the geometric models aren't linked to explain the actual machining times. And third, the testing was limited to just 3 projects, 1 material marble and 2 tool types. These narrow scopes make it hard to generalize these results across broader conditions.
Next, moving on to the validity of the results. We evaluate the validity of the result and author's interpretation of the data. Overall, the findings are internally consistent. The zigzag toolpath achieved the shortest machining time for project P1 and P2, while the one-way strategy was consistently the slowest across 3 projects. In project P3, the one-way strategy even required approximately 4 times longer than the zigzag strategy. The author's conclusion that toolpath strategy has a significant impact on machining time is therefore well supported by the reported results. In addition, the G-code optimization process is clearly presented, with machining time reduced from 20 minutes to 2 seconds, to 15 minutes and 33 seconds, and finally to 30 minutes and 33 seconds. These intermediate values made the improvement transparent and easy to verify. However, one limitation is that the study does not include repeated experiments or statistical analysis. As a result, the reported percentage improvement should be viewed as observation from a single case study rather than the statistically validated findings that can be generalized to different material, geometries, or machining conditions.
Okay, so we now move on to the next segment, which is discussion of limitations. So in the paper, there is no specified limitation section, but there are some omitted aspects, which is first, the single material scope, second, the small number of projects examined, third, the absence of repeated trials for toolpath strategies, fourth, the reliance of proprietary software. So these software's optimization algorithms are undisclosed, so therefore limits the reproducibility of the G-code to other researchers. So this lack of transparency may cause readers to overgeneralize the reported time savings of other materials. Okay, so next part is the significance of findings. So the findings successfully address the problem, which is to reduce cycle time in stone processing CNC operations, while also limiting and avoiding implications for production cost and throughput. So below here is the outcome, which is concrete replicable workflow for practitioners facing the limitations in iCAM 3D. So overall, 30% of improvement is recorded for project P3, which proves findings to be of general interest to manufacturer, even though it is drawn from limited set of test conditions.
Okay, before we finally conclude, for ethical concerns, none at all were reported. Okay, next. Okay, finally to our conclusion. Next. Okay, the study gave clear evidence that strategy selection does affect machining time, and it showed that a practical multi-software workflow for further reduction through G-code refinement. The paper did have weaknesses, however, it was just purely methodological. So therefore, the paper is still a valuable contribution to time-efficient machining practices. However, its scientific claims would benefit from broader validation across materials and geometries. So that is all from us. Thank you so much.